Already got a 2007 Chevy Tahoe 5.3 four-wheel drive. Just wanted to show you how you could apply a function generator to a vehicle for troubleshooting. If I had the new MaxAssist Ultra scan tool, it has this function generator built into it. I don't have the new one. It's like a $5,000 to $6,000 scan tool, but I got one of their older ones here. Sorry about the glare. So I'm gonna do a wheel speed sensor check. So what I'm gonna do is, you got two wires going to the wheel speed sensor. Sometimes they're square wave, sine wave, triangle wave, depends. I'm gonna put these breakout leads in here and show you what this signal reads on the oscilloscope, and then we'll go from there. Let me show you how I have this set up. So I got my breakout leads from the AS kit I have. Positive, negative channels going to my oscilloscope so I can break out. This is where my thumb is the wheel bearing side. That's the EBCM side, electronic brake control module, where all this data goes. And the kit that I'm using is from AS Wave here with all my breakout leads. Got my scope turned on. So try to turn this while I watch it. I'm going to go ahead and turn the wheel, spin it like this by hand. I should get some kind of waveform, but you can see it there. It's kind of like a square wave. So we'll go ahead and pause that. Rewind. If you look and get an idea here, looks like a square wave from 400 millivolts to negative 400. Positive to negative 400 millivolts roughly. We can adjust our frequency from there. Obviously this thing's reading correctly for this vehicle, but what I'm going to do now is I'm going to introduce a signal into the harness going into the electronic brake control module with my function generator and read it on the scan tool. So I forgot to mention, when I'm doing these tests right now, I have the key on engine off for the test that I just did to show it on the oscilloscope. But if you look at this scan tool here, we'll look at the data, why spin the tire. So I'm going to go ahead and spin this tire by hand, which we just read on the oscilloscope, key on engine off. But you can see the left front is reading, right? Obviously, because I'm spinning it. When it stops, it goes to 0. But now like I said, we're going to introduce a signal into the harness going to the EBCM. Why would you want to use this test? Well, if you know, say a suspected bad wheel bearing, say that wasn't the issue, but there's a wiring issue from the connector to the harness through other connectors to the electronic brake control module, we could introduce a signal in there with the function generator and try to troubleshoot that. All right, so now what I want to do is send a signal into this harness going to the electronic brake control module. So I got my leads out there, got key and engine off, scan tool pulled up, data, and I need to set my function generator up. So you got your frequency. We're going to go on 100 ohms, or not 100 ohms, 100 hertz. Then coarse adjustment, your fine adjustment. We're going to go on to a square wave because you got triangle wave, sine wave, and square waves. We're going to go on this square wave. Don't worry about the sweep. Don't worry about the offset. And we'll get the amplitude set to plus or minus 400 millivolts. We'll go ahead and get that scope set up right now. We're the function generator. I got my leads back into my oscilloscope to my computer to set this frequency and amplitude up so we can simulate wheel speed. Alright, so I got the function generator on. I'm going to go ahead and get my amplitude adjusted, which is this button here. I'm going to go plus or minus 400 millivolts. So if I increase it, it'll go up obviously, but I want to go to plus or minus 400 because that's what I read on the vehicle, roughly. All I want is to introduce a signal into it. So I got plus minus 400. I got a square wave because I'm set on square wave, because if I move it to triangle, or that's not triangle, that's sine wave. But you can see the different functions there, but I want a square wave. Adjust my frequency now. Adjust back. And all I'm doing is this button here for frequency and hertz. So that's something like we had there earlier, plus minus 400 for amplitude and whatever that frequency is, which you can measure it out, but I'm not really concerned right now. But just to show you, if you change this function button here, I just moved it to a sine wave, and you can see the sine wave. You can do a triangle wave, you can do that triangle wave, or you can go back to square, which is right there. There's another type of square wave there, another type right there. We're going to go back to this one. Plus or minus 400 millivolts. Frequencies look like what it was. The frequency will determine the RPMs. And obviously this thing can go up to 4 million megahertz, but we're not worried about that. So now what we're going to do is plug the leads in from the function generator into the harness of the vehicle and read the speed on the scan tool, because right now we're reading obviously 0 because we have nothing hooked up. Already got the function generator on, hooked up. But if you notice, our left front wheel speed is reading 0. I noticed on the amplitude on this, we had it set to plus minus 400 millivolts, but I actually have to increase the amplitude to read a couple volts, and then it'll read. So if I increase this amplitude while you watch this scale, that will read miles per hour. So I increase the amplitude, and if I was to hook it back up to the oscilloscope, it'd be around plus or minus 4 volts square wave. That's what this thing is outputting. I've never tried the other waveforms on it. I'm sure it would work as well, but what I found on this vehicle, you would think it produces triangle or sine wave, but what it's producing, because I think there's a bias voltages and there's some kind of square wave, which we picked up on the oscilloscope. Now if I adjust my frequency, that'll change my RPMs. So it says my left front's 11.81 miles an hour. If I increase it, you can see I'm going up. I'm just turning the dial. That's on the 100 hertz scale. I can go up to the 1K scale, and I can change it that way. So I can go all the way up to 99.42, it looks like. What I'm doing right now is telling that brake control module that this front left speed sensor is going 40.39 miles an hour with the function generator, which tells me the wiring from this pigtail through all the connectors to the electronic brake control module, which is under the vehicle on this one on the frame, is all good to go. If it didn't read on the scan tool, if it didn't read the miles per hour on the scan tool, when I have my function generator hooked up, I would have to go see if it's a connector issue or if it's a wire harness issue back before it. So now this vehicle's good. I'll put it all back together, clear all the codes. There's nothing wrong with it, but I just wanted to show you that how you could use a function generator to do that. And you could also use it for cam crank waveforms, anything that sends a signal out. You just kind of know what the signal is, and you can use it for troubleshooting. The new MaxiSys Ultra has this built into it. I don't think we use it a lot, but again, it is very handy to have. And that is it for this video.